Hello students, in the last lecture we have studied transverse wave and their 10 properties. Now we are going to study reflection of transverse wave and longitudinal wave with different examples. Let us understand what is reflection of a wave. When a progressive wave traveling through a medium reaches an interface separating two media, a certain part of the wave energy comes back in the same medium. The wave changes its direction of travel. This is called reflection of a wave from the interface. In order to understand the concept of reflection of transverse wave, let us discuss the first example. In this example, take a long light string AB. Attach one end of the string to a rigid support at B. Here, the string is the rarer medium and the rigid support acts as a denser medium. Now, by giving a jerk to the free end A of the string, a crest is generated in the string. Now, observe what happens when this crest moves towards B. And secondly, observe what happens when the crest reaches B. In example 1, when crest moves along the string towards B, it pulls the particles of string in upward direction. Similarly, when the crest reaches B at rigid support, it tries to pull the point B upwards. But being a rigid support, B remains at rest and an equal and opposite reaction is produced on the string according to Newton's third law of motion. The string is pulled downwards. Thus, crest gets reflected as a trough or trough gets reflected as a crest. Hence, from example 1, we can conclude that when transverse wave is reflected from a rigid support, that is, from a denser medium, a crest is reflected as a trough and a trough is reflected as a crest. Again, one more thing we can conclude here is that there is a phase change of pi radian on reflection from a fixed end, that is from a denser medium. Now, let us discuss example 2. In this example, we have to study the reflection of transverse wave from a denser medium to a rarer medium. See in the diagram, take a long light string AB, attach the end B of the string to a ring which can slide easily on a vertical metal rod without any friction. Here, string is the denser medium while the end B attached to the sliding ring is at the interface of a rarer medium as it can move freely. Now, give a jerk to the free end A of the string. Observe what happens when crest reaches the point B attached to the ring. Also, try to find the reason of the observed movement. In example 2, we observe that when the crest reaches the point B, it pulls the ring upwards and causes the ring to move upward. the wave is seen to get reflected back as a crest, and no phase change occurs on the reflection from a denser medium. In order to understand example 3, take a heavy string P and a light string Q and join them. Suppose they are joined at point O. Here, heavy string acts as a denser medium while light string acts as a rarer medium. Produce a wave pulse as a crest on the heavy string P moving towards the junction O. Observe the part of wave pulse reflected back on the heavy string. Produce a wave pulse as a crest on the light string Q moving towards the junction point O. Here, observe the part of the wave pulse reflected on the light string. What difference do you observe when the wave pulse gets reflected on the light string and when the wave pulse gets reflected on the heavy string? Try to find the reasons behind your observation. In figure 3, look at figure 6.3a. We find that a crest traveling from the heavy string gets reflected as a crest from the lighter string. That is, reflection at the surface when a wave is traveling from a denser medium to a rarer medium causes a crest to be reflected as a crest. Similarly, look at figure 6.3b. Again, we may find when a crest travels from the lighter string to the heavy string, the crest is reflected as a trough and vice versa. Next article is reflection of a longitudinal wave. Consider a longitudinal wave traveling from a rarer medium to a denser medium. In a longitudinal wave, compression is a high pressure region, while rarefaction is a low pressure region. When compression reaches the denser medium, it tries to push the particles of that medium, but the energy of particles in the rarer medium is not sufficient to compress the particles of the denser medium. According to the Newton's third law of motion, an equal and opposite reaction comes into play. As a result, the particles of a rarer medium gets compressed. Thus, when the longitudinal wave travels from a rarer medium to a denser medium, a compression is reflected as a compression and a rarefaction is reflected as a rarefaction. There is no change of phase during this reflection. Now, let us discuss the reflection of longitudinal wave from a denser medium to a rarer medium. When compression reaches a rarer medium from the denser medium, it pushes the particles of rarer medium. Due to this, particles of the rarer medium gets compressed and move forward, and a rarefaction is left behind. Thus, a compression gets reflected as a rarefaction. Similarly, a rarefaction gets reflected as a compression.